Hello all. So first of all, a very warm welcome to the course of Introduction to Machine Learning instructed by Professor Balaraman Ravindran from IIT Madras. So basically, let me introduce myself first. So I'll be your teaching assistant for this course. Myself, Shreya Bansal. I am a PhD PMRF scholar in IIT Ropar. Okay, so in this session, every Tuesday we'll meet from 6 p.m. to 8 p.m. and we will try to solve some of the problems that are associated with the course content that is already available to you. So already week 1 is given to you all, week 2 has already been started. So in this course, in these sessions, basically, we will try to solve questions. We will try to learn, take your queries if you have any problems, and I'll try to give you a glimpse of your week also. Okay, if someone has not taken up the week course, so I can start with some small basics that what in the course content of a particular week, and then we'll go through the previous year questions so that you can have an understanding of the content as well as you will be able to solve queries also. All right, so good evening to all of you. And Shweta, right? Yes, you can ask your doubts as this is my first session. So everyone came here, and I just start with what we are going to have in these sessions. Then you can obviously ask your doubts also. Okay. So, all right. Okay. So basically, let me know about you first that may I know from which courses you all people are here so that it will be easy for me to go through means to include the terms according to that. Okay, because there are lot of terms related to mathematics, maybe there will be terms related to machine learning. Okay, so you can either type in the chat box that from which courses you are. Mathematics, great, Pradeep. Okay, I have seen some people who are from BTech also, BSc Statistics. Okay, Priyanshi, Physics. Oh, nice, very good. All right, Instrumentation Engineering. All right, BTech CSE Core, CSE. Okay, all right, AIML, MCA. All right. So you can see, you all can see that from various departments, from various domains, people are here to learn about this course, machine learning, right? So you all can get an idea that how important is this course, right? So basically, I'll start with basic terminology of machine learning, and as you all have the content and related mathematical terms are there, so I will be basically trying to give you the glimpse of machine learning in the real life so that you can relate your questions, and you can have an understanding that where this machine learning or these AI based things are applicable in our real life. Plus, it will be very interesting for you to solve questions as well. Okay, so basically, what I used to do for when I used to learn these courses, I use two types of platforms on two types of you can say understanding on which I try to learn these courses. First is your real life. Okay, second is because these machine learning, AI, deep learning, all these things comes under computer science branch, which is ultimately a branch of mathematics. So try to associate all your algorithms, all your concepts in mathematical form. So it will be very easy for you to understand on the level of question solving, and obviously for your projects also, because this is a very important subject. If
Okay.
hello. Okay. So, okay. So, and at the last of this session, I will share a feedback form to you all, so that feedback form is for me itself, so that you can actually give your suggestions and feedbacks that what you want to do in the next session, right? Because this session is in the late week. It means we will be meeting every Tuesday, and your week starts from last, right? You have the content of week 2 also. So that's why for the week 2 content, you have the content with you. And if you want to have some queries, some doubts, some concepts to be included in this session, you can simply fill that form. I'll try to keep that in my slides and content. Okay, so this is all about how we will be conducting this session. Next thing is Shweta, you have doubts, right? So we have let's wait for 2 minutes so that all the students can come here. Till then you can ask your doubts. Shweta.
Hi, good evening, ma'am. Actually, my doubt is during we had a couple of earlier problem solving sessions also, and in all these sessions as well as in the lectures, I saw examples on KNN based regression. But how to do the regular linear regression? Can you just illustrate with an example just by writing by hand? Any one example?
Okay, okay. Okay, sure. When I start with that linear regression, I'll give you a glimpse of the how you can solve it. Okay. Presently, I don't have an example right now, but I'll give you an idea so that you can easily solve that. Don't worry for it. Okay.
Okay, thanks.
Okay.
Yeah, hello, madam.
Good afternoon. Yes.
Madam, actually, I'm a working professional for 8 years. I completed triple E, BTech triple E. Yesterday, I joined this course.
Okay.
So, where to get the materials?
How to get the materials?
Yes, yes, madam.
Okay. You have joined the course, right?
Yes, madam.
Okay, so you will get a link, or I think you also get an email also in which online courses like that the email start from, and you will get the notification that this is the week content and this is the assignment.
Okay, okay.
Did you get that?
No, madam. Yesterday, from yesterday, I missed the class. The day before yesterday, I joined.
Okay, okay. Actually, these classes, na, you have four classes for these problem solving sessions, right? So, in which these are not one person will choose one topic, another person will choose another topic. No, it's not like that. It's just that ki we will try to solve your queries at different times, because the student strength is very large, so we can't say that give the one time, so that we will give you a relaxation that there will be four times four people are there to help you out with that content. So basically it's not related to class. For the content is already available, and the videos and the books are given to you, instructed by Balaraman sir, right? So all the session contents are already emailed to you. There is a portal on which the week-wise content is there. The quiz or assignments are there, means multiple type questions, and there is a deadline for assignment also. Okay, so just check it out. If you have the email or not. If you don't have the email, then please you can email the query. There is a query email. You can email them so that your content will be visible to you. Okay.
Okay, madam. Thank you,
Okay.
madam.
Okay. Okay.
Excuse me,
Dipali.
ma'am.
Yes.
Ma'am, can we have a revision through bias and variance and related problems?
Bias and variance. Okay, I'll try to keep that also. I have some of the problems, and because this is my first session, I don't know that you will need the problems of a specific topic, but if time permits, I'll keep it in another session, next session. Okay,
Ma'am,
just
the reason why I asked was because I attended the previous live sessions, ma'am, but I didn't find them having many questions related to bias and variance, so I'm not much clear on that
okay.
topic.
Okay, I'll touch that topic. So let me first finish that. Then, if you will not able to understand still, we will further continue. Okay.
Yes, ma'am, thank you.
Okay. 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 Dipali. Dipali, you have raised your hand. Do you want to say something?
Yes, ma'am.
Uh, Go ahead.
Hello.
Hello. Hello. Yes, you are audible, Dipali. Go ahead. Okay, I think I am not audible to you. All right. Till then, we'll start our session. All right. So let me start with the week contents. So week 1 basically have basic machine learning terminologies and some important paradigms in this week. So first is the introduction to machine learning. Second thing, supervised learning. Third, unsupervised learning. Fourth, reinforcement learning. Five, statistical decision theory, that is related to regression. Next, same statistical decision theory related to classification. And last is bias variance. So these are the contents are in your week 1. Okay, so let us start. So basically, what is machine learning? Machine learning is a branch of artificial intelligence, and you all know what is artificial intelligence. What is artificial intelligence? As the name signifies, the intelligence embedded in the machines. As the God made a intelligent animal on this planet, that is human. So human is the most intelligent person, right? Now what we wanted something to assist human, like humans are assisting themselves. So AI comes into picture. Let us dwell some of the intelligence that is related to human into the machine, right? So this is a major branch, that is artificial intelligence. Now question arises, what is intelligence? Is it a qualitative term or a quantitative term? So just let me know, is intelligence can be quantified? Yes or no?
Yes, ma'am.
Hmm? Can you
Yes.
quantify intelligence? No, you can't. Can you say that this person is intelligent or this is not? No. So it's an qualitative term, right? So qualitative term means we don't have a particular performance metrics or we can't measure it. So basically, why we call human an intelligent animal? Because humans are adaptable to the dynamic environment. Why they are adaptable? Because they can learn from their environment, right? Like when a kid born, he don't know anything, right? We started to learn something from our parents, we started to learn something from our teachers, we started to learn something from the environment. So that's how we wanted machine to learn from its environment. That's why this term was coined as machine learning. So the Tom Michel in 1997, as you all have gone through this definition, I'm very sure. So basically, I'm not going to repeat these definitions. Why I have written this definition is to give you three important keywords, that is experience, class of task, and performance measure. I told you intelligence cannot be measured. But you see here, there is a term of performance measure here. Q, we say we can't measure intelligence, but when we give exams, we got return some marks, right? That's how we say that whether we pass the exam or not, right? So we are not associating intelligence with this performance measure. We are just giving the performance measure for a particular task for a machine, because if machine is not good enough, why we will use them, right? So that's why this machine learning terminology has three important things. First is experience. In human perspective, the experience, it means what we learn from each other. Let's say if you are in a class, the teacher is teaching to you, the experience you are getting is from the teacher, right? A small kid who is just born, if you give that kid some type of toys, let's say, so that building blocks, if you give that kid of different colors, so what you will see intuitively, that kid is able to see colors, and he will try to pick the color which fascinates him. Why? Because this is the experience that he is getting by visual, by seeing them. Next is the class of task. Class of task means something we want to achieve, something we want to do. That means these are the class of task. It means if you are coming in this class, it means you want to learn this subject machine learning. So your aim is, your task is to learn this subject, to get an idea what this subject is. So that in future, after this class, if you have a complete knowledge and if we give some problems in your real life related to machine learning, you are able to solve them. So let us say you get good marks in this class, right? It means you can associate good marks as a feedback, good feedback, that okay, now I am able to get good marks. It means I am able to solve some of the real life problems with this, right? This is a very vague term in this way. So there are many things associated with it which we will learn next. The important thing is, in any machine learning algorithms, in any machine learning concepts, you will see one, learning, that is experience. Secondly, what you want to achieve, that is your objective, or we can say the class of task, and obviously the performance measure. So you can always associate this type of thing as classroom teaching, right? You are coming in the class to learn, so it means your objective is to grasp knowledge, that is your task. How you are grasping knowledge? Through a teacher. This is your experience, and after, when you give exams related to the questions what you have learned, we give marks to you, so that marks are your performance measure. Okay, so important is why task, performance, and these experience, right? Yes, Ansh, want to say something?
No, ma'am, no, ma'am.
Okay, okay, all right. So important is what I am telling you, why these performance measures are important, because many things are qualitative in nature, right? So if the things are not measurable, then we will say like something seems to improve, but what to improve? How you will say that ki, okay, let me say ki, do you all use chat gpt, yes or no?
Yes.
Yes,
Yes,
ma'am.
yes, yes,
Ma'am.
right. And you all like it. Why? When you give some query to it, it gives you a very concrete answer and you like it. Oh, I'm like burden free. When I search it on Google, it will give me some links. But now in ChatGPT, it is giving me the results on the basis of my input, on the basis of my query. You will like it. Let's say you want to buy a smartphone, right? And you search it on Amazon that these are the smartphones. Next, you get some recommendation regarding the smartphone and you find it good. Okay, this computer, this AI, this internet is actually giving me the personalized content to me. And it means why they are giving to you, because they are tested on so much data and their performances are measured. That's why it is made public to you, right? Agar if there is no performance measure, how you can say that ki this algorithm or this concept is better than the other one? So that's why performance measures are very important. So examples of clear performance can be marks, as I already told you. Okay. So think of learning as training for a marathon. So if you are running a marathon, so what it be like? You are this task can be you want to run. It means your objective is to run, right? Your performance is in how much time you have completed that run, and your experience is when you have practicing about the runs. Obviously, let's say ki there is a game, basketball, when you are practicing with your friends, it means your quality improve. You get to know ki okay, from this move I have to use this action. So it means you are developing your experience, you are learning again and again. So these are the clear things: the task, performance measure, and experience. They should be very clear to you. So in other form, you can say you should know what is the input, the processing, right? The processing is the thing that you want to develop, and finally the output you should know. If you have the output and your algorithm or your software is giving you something, you can easily get a deviation that the software what is giving to me is not what I wanted. So that's why you need some performance measures also. Okay, so there are different machine learning paradigms. So as I told you that learning is the important thing. How you are learning, a small example I have given to you. This is a class. I am telling you, okay, look, these are the paradigms: supervised, unsupervised, reinforcement, which you will get here, right? Before, you don't know. I am giving you that, look, these are three paradigms. Now you will learn this concept. Okay, ma'am has told me that this is supervised, this is unsupervised, this is reinforcement. Now I know it. Next time when someone asks you, because I have already told you, you try to grasp it and you know like these are the paradigms. Another example, let's say when we were small, our mother of our parents told us, look, this is a cat and this is a dog. Both have four legs, both have tails, both are small creatures. How you will distinguish them? So there are some features on which you learn that, okay, cats are like of this structure, dogs are like of this structure. That's why it is called supervised learning. Supervised means the output is given to you when you are in learning phase. So basically when you are experiencing something, someone is there to guide you. Okay, you are not correct, this is the correct thing. So let's say ki, you are training a small kid ki these are the cat and these are the dog. Let's say ki there is a new species or new breed of dog came into, and he said, okay, this is a cat, but you say no, this is dog. It means you are there as a supervisor for other learner to learn that, to experience that, right? So this is called supervised learning. It means the output, the ground truth is available to you. Now the algorithm that you will develop will try to mimic that output, right? Let's say I told you to solve questions of mathematics, right? 2 plus 2 is 4. How do you calculate it? 2 plus 2, that is 1, 2, 3, 4, it is equal to 4. Similarly, you can grasp this knowledge and apply it 2 plus 3, 2 plus 5, 2 plus 7, and someone is there to check you out. So it means these are supervised way. Next thing is, now this supervision is of two types, means classification or regression. Why? When I am telling you, okay, this is cat, this is dog, it means I am labeling something, right? Let's say I say, uh, 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 what do you think the weather of tomorrow? Will it rain or not? So you will say yes or no, right? If I ask you, okay, what will be the temperature of tomorrow? So it will be a number. So there are two things. We process these two things separately. That's why supervised learning is of two types. So first is classification. As the name signify, classes. There will be classes given to you, cats, dog, flowers, and ratings, right, which are not measurable basically, so non-quantifiable. Second thing is regression. It means the output will be a number. What will be the temperature tomorrow? And let's say there are some crops, right? There is a field in which some maize crops are grown. So I want to predict what will be the yield of the product, right? All this produce. So I'll just want to get an idea that after the full season complete, I'll get some 3,000 quintals of maize this year. So how you are predicting it? You are predicting in a number. So number is quantifiable. So if the output is non-quantifiable in the form of label, it is called classification. If it is quantifiable, it is called regression. Okay, done. One type of learning, it's very easy. Now question arises, let's say I don't give you an idea that this is dog or this is cat. As I told you, when you give some blocks of different colors to a small kid who don't know to speak, who don't actually know anything, right? So he can just visualize it and try to separate the two colors. It's very easy to see for small kids, right? These are the activities that parents do with their kids to get an understanding of color, texture. It means they are creating patterns what they have been given to. So this is also a type of learning. So that's why the if from the supervised learning, the question is always you will not have the output. So when you not have the output, you will just have data that is called unsupervised. So unsupervised means it means you try to find patterns out of it. So there are two types of unsupervised learning, clustering and if the output is quantifiable. Yes, Grishma, if the output is quantifiable term, it means it is in the basically in the form of number, right? Why I told you quantifiable? Let us say I want to predict the rating of a film, right? Last आपकी एक film thi, I want to get out the ratings. So ratings can be in between 1 to 5. 5 means best, 1 means poor. So this 1 to 5 is actually a number, but the main aim is not to quantify, it's just labelize that whether the film was good or not, and in between the gray shades, good, very good, right? So that's why I usually associate regression with some quantifiable quantity, jaise ki temperature, whether it is 40 degree, 30 degree, 50 degree, so you can quantify it, right? So we
That's
were
quantifiable discrete, ma'am, or continuous?
uh, discrete and continuous both can come in regression. Ultimately it is in number, but a quantity should be there. Okay, let me give you an example of regression. So basically supervised learning means output is given to you. It means what you want is already, some supervisor is there to make you understand, okay, this is what I want. Let's say I want to predict the temperature of tomorrow. Okay, I have some data, I want to predict today's the temperature is, let's say, some 16 degrees Celsius, right? So what will be the temperature of tomorrow? So this temperature can be 16.1, 16.5, 17, 18, 19. So there is a huge range, right? So it means, and it is quantifiable. B means 16.2 and 16.3, you can have many more values in between the two also, right? So that's why these type of problems are called regression, because at the end I want a number, right? Classification means I don't want a number, I want a label. Whether, let me reframe this question again. I don't want you to tell me the temperature of tomorrow, I just want you to tell me whether there will be high temperature or low temperature or moderate tomorrow, right? So these are three classes: high, low and moderate. These are not numbers. So ultimately these terms are comparable, I can say that, not quantifiable. You can't say what is high. High can be in between 40 to 50. High can be, for someone it can be 30 to 40. So high means something that is maybe above some threshold, but that threshold is not given to you. So basically we just associate some qualitative term in this classification generally, like that, the names, right? Entities, dog, cat. You can't say na this dog and this cat are completely differentiable, no. But you can say ki this dog has 3 legs and this dog has 4 legs. This is quantifiable. So am I clear to you who have asked about regression? If the label is a number, then it's okay. Okay, let me say that like rating. Okay, so which gives
Ma'am,
this
please explain this once more, the regression.
regression means basically the output is in a form of number. Someone asked me, Pankaj, you want example of discrete results. Okay, let's say um, age can also be actually if I tell you that from the model can have somehow continuous value also. For example, let me give you an example. um, I have given you a data of a class, okay, in which some students are there, and I give you the age of the student. The age you always write as a full discrete number. I know you can write it at 4.5 years, but generally it not happen, right? So you either you write 4 years or 5 years. I give you a discrete actually for training. But when you create a model and you want a number out of it, it can map to continuous values also, right? So discrete particularly there is not a particular example, because if you are going to train a system for ratings are not regression tasks, they are classification tasks. Whether you give 1 to 5 ratings or something, because 1 means 1, 2 means 2, there is nothing called 1.2 and 1.5, right? So I don't want to have in between values in a range. If I want specific things, then it is called classification. Is that clear? Am I able to clarify?
Ma'am, as someone previously asked, what if a label is a number, ma'am, in case of regression?
In case of regression, it's a case of classification. That's why I given you example of ratings. Like, look, you want to give a rating from 1 to 5, right? Of let's say of a movie. So you if you are giving a rating of 4.5, it is, if it is eligible to you, then it's a problem of regression. But if you discreetly say that either I want 1 or 2 or 3 or 4 or 5, it is called classification. Am I clear?
Yes.
Because the output from regression is in continuous form. If it is allowable to you, then go, good for it, good for you. If it is not, for example, counting, right? When you are, let's say you are counting some number of people, you are giving you are asking for discrete example of regression is, if you are asking for, let's say ki I want to count the number of people in this room, right? The number of people cannot be 4.5, but now from experience I am telling you, if you are creating a regression model, then after getting the result, you will either means round off it, or take means either you take a ground value or the floor value of it. Okay, so basically the output from a number is a continuous value. Ab now it depends on you which type of task you are performing. If your task is to get the age of a plant from the data, the output is in the form of number 2, 5, 6, but 2.5 and 2.8 is allowable. You can simply say, okay, this plant is 2.8 weeks of age. 2.8 means 0.8. You can consider them as in days. But if I say you count the number of plant, and if it is giving you 4.5, then you will say, yeah, what are you talking about? 4.5, if there is a count? No. But still, it's a differentiable number. It's not class. Okay. Clear? Shall I go ahead? Okay, thank you. So next thing is unsupervised. So basically unsupervised is you don't know about what these classes are. For example, I'll give you a small example. You all know about cricket, right? So in cricket, let's say I give you a data in which uh, some players are there, their information of the previous matches are there. So what the information include? It includes some the runs they have scored, the wickets they have taken. Okay, especially these two things. So basically now from these two things, and I don't give you anything. I don't provide you whether the person is a batsman or something. So can you get an idea that who is the batsman out of those? There is a data in which two things are given to you: the number of runs scored and the number of wickets taken. So can you get an idea that this person is a batsman or this person is a bowler? How you can get an idea?
The
Yeah, if
match.
one is more, they can be a bowler, and row scores of more, they can be a batsman. Like that.
True, it's perfectly fine. It means there are two variables given to you: the number of runs, the number of balls. If the data is saturated over high number of runs and low number of wickets, it means most probably that person is a batsman. If the person score more number of wickets rather than runs, then basically it can be associated as a bowler. And those who are best at both of these things means you can say these are the all-rounder, right? So these terminologies, all-rounder, batsman, bowler, are labels, but this is not given to you. I didn't tell you कि okay, this person is batsman, this person is bowler. You find it out because you have a knowledge. You can pattern out the things out of the data. Similarly, as you can see from this figure, so you can see some clusters are created. So these clustering techniques comes under this unsupervised learning. So how you find the cluster? The cluster which are near to more runs forms one cluster. The data points which are near to more wickets is another cluster. And third cluster is in between of the two. So now the first cluster, the second cluster, the third cluster. The computer will tell you, okay, these are the clusters. Now, associating the features, you can label them from your human knowledge that, okay, this cluster is means batsman, this cluster means bowler, this cluster means all rounder. So basically, unsupervised learning say कि the data is given to you, now process it, find out patterns. So this is called clustering. Clustering means grouping. Grouping on the basis of similarity. Similarity can be on the basis of color, can be on the basis of texture. These are the common things which are visualizable. But other things, mathematically, we can say if I plot the data on a graph, right, and if two data points are near to each other, then they are in the same cluster. So the distance between 2 points is the measure of clustering. Yes, similarities. All right. So this is one example of unsupervised. Another example is you all go for marketing, right? So let's say कि if I want to go and buy a laptop, right? You got recommendation related to laptop, but do you have some time? Just let me know. Do you have recommendation for laptop bags, tablets, stylus pen, or these accessories associated with laptops? Yes or no? You all know these shopping sites recommendation. If you search for laptop, it will give you recommendation of different types of laptop. But do you just get the laptop recommendation or related to the products which are related to your search? Yes, let me know. Yes or no?
Related to the search.
Right? So it means these are called association. It means it's a old thinking. If you are going to buy bread, you will buy butter. So what these market companies do, if they decrease the price of bread, they increase the price of butter or jam or something that is associated with it. But what we see that, okay, the price of the bread is low, let us take it. But the other thing that is associated with it has risen up the price. So that's how these companies make profits. So this association is very important. Which product is associated with another thing? So these recommendation system, market basket analysis, this all comes into association, unsupervised, because you don't know that bread is associated with butter. But after time, when your consumers on your platform are buying two things or three things or four things in associated with each other, you try to make the association according to it. So and other thing also, if you have noticed, I don't know, if you, let's say, add some let's say you add some jeans in your cart from Amazon or Flipkart or anything, right? So what you find it as, there are some recommendation like, if you add this pair of shirt, then you will get this percent of discount. Why? Because many of the customer maybe have bought those things together. So that's how this market basket analysis, these online platforms, these recommendation platforms are using this association rules to give you these good recommendations. Okay. So there are two things, that first is supervised, second is unsupervised. Now, let me know, let's say the task is now more complex. You want to ride a cycle, okay? So what will you classify this task? Riding a cycle, if you want to learn how to ride a bicycle, is it related to supervised or unsupervised? What do you think?
It's both reinforcement.
Okay, you know about reinforcement, right? So basically, you say, okay, related, right? Those who know reinforcement learning, obviously, yes, it's a reinforcement. Means now we thought there are two types of learning: supervised, that is called classroom teaching like thing, unsupervised, where nothing is given to you. But do the humans only use these two type of learning? No. How human learn is, because human lives in a dynamic environment, and this dynamic environment, what it means is, let's say uh, I try to learn to ride a bicycle. When I will try to learn it, there will be some actions that I'll perform, but according to the environment. Let's say I have somehow learned it in a basic form, and uh, wait a minute. Am I audible? All right.
Yes,
Yes.
ma'am.
Okay. Okay. So, what it means is कि according to the condition or according to the situation, you change your decision. So let's say कि I am just initial to ride a bicycle, and there is a steep peak, steep ground, right? And I'll say कि okay, no, I'll just go through it, and I just keep the speed of my cycle as I have in the simple ground. So what it will obviously have an adverse effect for me, and I can just fall down. If I get fall down, it means I get in my head, okay, I will not ride the bicycle like this on this steep ground. That's how we learn. So that's why this is called as reinforcement learning, where some feedbacks are given to you and you learn from those feedbacks, like when you play games, right? So let's say कि many of you have played chess, right?
It
Yes
is
or
same
no?
one gone to fire and God.
Hello?
Maybe it is same like someone got to fire and get a precaution that next time I am not try to got into.
Yes, you can say that. Yes, true. So basically, I was telling you that you all have played chess. You all know the rules. The rules are given to you. Okay, these are the means modules given in your chess, and this is how they make a move. So the rules are given to you. But when you play more and more with your opponents, you get to know the strategy. You learn to play better. You learn to have your own strategies. Strategies can be built, rebuilt. So how they are building? On the performance, on the game result, that from this move I have lost the game. That's why I should not choose this move. From this move I make plus points in my game. So it means these moves are important for me. So these are called feedbacks. They are rewards. So according to this feedback, according to these rewards, yes, Manaswini, machine will learn through mistakes. You can say that. So this mistake word, you can treat, we call it as regret. So as rewards means plus points, regret means negative points. So let's say this robot, right? As you can see from the image, the ball is throwing to a robot, and robot should grasp it. If it is not grasping it, it means it's a regret, it's a negative reward, and it should not do if he is training continuously. So this is a third type of machine learning paradigm, that is reinforcement. All right. Someone is here. Bias and variance. Yes, I'll go through it. Sure. Okay, so these are the three different paradigms. Now, important is what performance measures will you use, because I am telling you from the starting. Let's say you built a system to predict the temperature of tomorrow. Then how will, why should I purchase your system? There are many more systems in the market. So there are some performance measures associated with each type of learning. The first is supervised, unsupervised, and reinforcement. We will be going through all this. So in supervised, it means you know the actual value, you know the actual class. So how far your model prediction is from the actual value is the measure of performance in supervised. Let us say, yes, the recording will be shared to you. Okay, don't worry. So how far the value? It means, let's say, I told you I have given you some dogs and cats images, and I told you, okay, look, this is dog, this is cat, this is horse, right? Now I give you some data, and I ask you, what picture is this? So we will talk about bias and variance after that. Let's move in this in the proper way, so that it can be easily understandable to all of you. Okay, so basically, the from the testing point of view, if I ask you, let's say I give you 10 images of cats and dogs, and I ask you to just classify them. Okay, so what I will do, after getting classified by you, I'll check it whether you have correctly identified or not. So number of errors means, or you can say the highest accuracy, the number of correct predictions or the number of incorrect predictions can be a performance measure, right? So let's say if it is a class cat or dog, so it means if you have identified cat as a dog, it means it is wrong. It means either you are right or wrong. It is more like TikTok when you do your multiple choice answer questions, and if the answer is point B and you have selected either A or C or D, it is all incorrect, right? So in the same form, this supervised learning works. Second thing was regression, right? So regression mein you don't have classes, you have number. So let's say I ask you to make a prediction system of predicting the temperature of tomorrow, and you say ki the temperature, ma'am, tomorrow will be the temperature like it's more be 16.7. Okay, and I check that the actual that is given to you, I should not say tomorrow, I'll just say कि yesterday का predict करना था, and I know the ground truth, that's why I'm giving to you. So yesterday में क्या था, आपने कहा 16.7, all right, but the actual was 18. So the difference between 18 and 16.7 is your error. So this is the performance. So this is how you calculate error, and the less the error is, the more the good is model, right? So now as you this supervised learning is like classroom teaching, na? So what you do is no, you can't say reinforcement learning is a subset of supervised learning, because in supervised learning the input and output are fixed. Okay, it means if you give some features, if you give some data, there is one label or output associated with it. But in reinforcement learning it is not the case, it's a continuous process. It means, let's say you say you are like, if you choose this decision, then your reward will be like this. If you choose this decision, your reward will be like that. It's not in the case of supervised, so it's in another form of, okay. So in supervised learning, basically, like I was giving you example, like you come to the classroom, right? So some teacher is there, he or she is teaching you, this is your experience, so you are learning. So let's say let's say we are having this class, I'm giving you some material, so these are input, these are output, right? Right, correct Gopal. Okay, so basically I'm giving you this data, that this is supervised, this is unsupervised, I'm telling you everything. Now at the end of class, what I do, I take some small test, right? So this small test is related to the knowledge that I have given to you. It's not exactly the same question. So what I have done, I have solved the question here. You learn how to solve it, okay? You try to mimic that processing for other inputs as well. So when I give you some test in the end of the class, you will, let's say there is a 10 marks test and you get 8 marks, okay. So basically first what you have done, you have trained your system, you have trained your mind on which I am talking, what I am teaching in class. So if I am teaching you 1 2 plus 2 is 4, 5 plus 3 is 5 plus 3 is 8, so I'm giving you this knowledge, okay. Now you are grasping it, somehow your brain neurons are working towards it, okay, this is how we should do. Now, this is your training, right? So, training generally, when you continuously train your system with more data, you will get efficient. Now, I take test. Sometimes what happens with some students, they are good at class, they give answers to the question related to the class, but जैसे ही test आता है, they got somehow, maybe their marks are not good. I am talking about the case where they are not able to generalize themselves on different questions, okay. So that's how we always keep some data which is used as testing, and some data which will train your system. So when you come in class, we give you some question and some related question we give you in test. We don't give you the same question discussed in the class. Why? Because we wanted to test you on some new data, right? So that, why? When after this class, after this course, when you go out in real life, you get some task which will not just the replica what you have seen in the courses, but you have some modules of the task related to that, you are able to apply your knowledge. So that's how a system is built and it is deployed in the real world. So first you have some training data, you have some testing data on which you do some tests. So those testing data should be very different or should be separated from the training data. So this is how these error performance measures are very important. Now, this is supervised. Supervised, you can say, ma'am, we know the output we wanted to achieve. That's why we can simply get that this is the error. What about unsupervised? So unsupervised means we worked on similarity and probability. Now, what I told you in unsupervised, we have data which on so that we can find patterns. How you will find patterns? You will find patterns on the basis of similarity or probability. Means the what is the chance that this laptop is associated with the stylus pen? Obviously more. And what is the chance that laptop is associated with bread? No, there is no connection between the two things. But this is our intuition, right? Okay, ma'am, can you once say again what is classification and prediction error? So, classification error means I give you an example where, like multiple choice question, whether you predict the correct class or not. Okay, so let's say I give you 10 images of different animals. Okay, so how many images you have predicted correctly is called classification accuracy, and opposite of it means how many you have not predicted correctly is classification error. Classification error clear hai? Is it clear? Classification error.
Yes, ma'am.
Okay, prediction error means now
Ma'am.
prediction is not just class. Prediction is means you want to predict temperature as 18 but your model predicts 16.7. Then what is the difference? 18 minus 16.7. Let's say you get 20. So it means 18 minus 20. You are 20. It means there is 2, right? The value is 2. It means 2-degree difference is there. 18 minus 16.7 is somehow 1.3, right? 1.3 degree deviation from the actual and predicted value. So this is in the number form. So that's why you average all those things. Let's say I have given you for let's say, what should I say? Okay, let's say I give you a task in which I give you photographs of 10 persons and I tell you, ask you to predict the age from the images. You say the first image is, ma'am, is of a kid of around 10.2 years, but the correct age is, let's say, 10.5. So you are 0.3 years deviation, right? Second image is, you say, ma'am, it's old a lady of 60 years, but the actual age was of the lady, let's say it is 61.3. So it is 1.3. So you add all these errors and the whole error is like taken as an average. Am I clear, Shweta?
So can we say that for classification error, the given data will be absolute, whereas in prediction error, we have to the predicted value will differ, ma'am?
Yes, classification error is for classification task and prediction error is for regression task.
Yes, ma'am. Thank you.
Okay, okay. So let's come back to the unsupervised thing. So unsupervised means your similarity or probability. So let's say I give you an example, right? So the data has some distribution always, right? We all, how many of you know about Gaussian distribution or normal distribution? Yes or no? Yes, very good, Pankaj, Arpan, very good. You all know about this, maybe Gaussian and normal. Why we call this as normal distribution? Because there is a peak, right? A bell-shaped curve. So that bell-shaped means that the belly is more like, it means average population is more, and okay, godly, okay. Look, let's say कि you have these humans, okay? So I tell you, let me give you an instance and you told me, give me who have said no. So let me ask you this. So there is a class of 12th standard, okay, in which the students are generally from which age? Let me know, a very important vague thing. There is a class in a school of 12th standard. So, what age students will be there? Let me know in the chat box. From your idea, give me a number. 17. There will be a range, na? Let's say 17 or 18, okay? So, 17 to 19 ki age. It's an average class age of a 12th standard. Maybe some student has some good points and some 15 or 14-year age student is there. It can happen. Some miracles are there. Okay. Other thing, something has happened to some student and maybe some 20 or 21 year of age, some person is admitted to that class. It means the average students are in between the middle range. And there are some of the, you can say, anomalies or minorities data. Okay? That's why that bell-shaped curve applies for all of the data you can imagine in this world. That's why we by default use normal or Gaussian distribution to associate with any type of data if you don't know. There are other type of data as well. Okay, because the distribution is important, how the data look like. So what I wanted ki the same type of data should reside at the same place. The other type of data should reside at another place. For example, let us say this is the data. Okay, let us say these are the number of runs, these are the number of wickets. Okay, let's say the person who have scored more runs are there. This is the data. But they don't have wickets because they don't get the chance to bowl, right? Some person, some players are having some wickets, but they got less number of runs, maybe like this. Okay? And some persons who are in the middle, it means they are good at taking wickets also, they are good at runs also. So it means some data is here. So you can see the similarity. So this similarity, this is called similarity, and this is called similarity. So this data is can be look like these dots, but if I tell you there is some distribution. So generally in mathematics, how we represent data, we don't use these dots. We use these Gaussian curves. So maybe this is from one distribution, this is from another distribution, and this is from third distribution. It means there will be some average, standard deviation, average, standard deviation, average. So the average which lies here has high probability that person is a bowler. Person who is near to this average has high probability that he is a batsman. Right? So that's why I have written here this this similarity or probability. So basically these are the important measures. It is means unlabeled data. Yes, correct, Gopal. It means unlabeled data. You don't have labeling. So you just find out the patterns. You find out similarity. The more the similarity is there, the high the probability is there, it means your algorithm is good. Okay. So for these things we have spread and purity. So spread and purity is related like let's say for unsupervised learning what we actually do is, let's say we have a task where data is not labeled. Okay, so what I do is, let's say I have a different kinds of plants with me. So I have some radish, carrot, and some mango, neem, and these type of trees are there. Okay, so what I am saying, telling you, I have some plants with me: radish, carrot, please switch off your mic if you are not. Okay, radish, carrot, mango, and neem. Okay, now you can see radish and carrots are plants, and mango and neem are trees. So if I don't give you any information, I just give you the images and you just plot them the data on a graph. So what you will find that radish and carrot will be near to each other, and neem and mango will be near to each other. Yes or no? Yes or no?
Yes.
Yes, correct. Now you don't know the labels. So what you will say, this is cluster 1 and this is cluster 2. Okay, fine, no problem. Now, so the data can be like maybe some cluster is there, right? Please switch off your audio if you are not asking any doubt. Okay, so let's say these are the radish and carrot, and these are mango and neem. But as you can see, these are two things, radish and carrot. So radish. Okay, okay, I'll let you know also. Actually, I am working in agriculture applications, so generally my examples will be more related to agriculture, but I'll try to give you some more ideas. The unsupervised learning real time project can be emotion detection. It's a very common project where you detect the emotion of a person using the images. Okay, so here you what you can see is this radish and carrot uh, are different, have different, somehow they are different plants obviously, so their data will be like this one and this one. This will be of radish, maybe this may be of carrot. This is an example. Similarly, mango and maybe neem can be here, but because these are two very near to each other, that's why I divided into two clusters, but they have all other things as well. So it means this unsupervised learning gives you an advantage that how many clusters. It can be seen as an advantage or another task that how many cluster you can get out from this data. For example, let me give you another example. When you search out the, let's say you are learning this machine learning, right? You write on Google machine learning books. So will you get only machine learning books, or you will get some books related to AI, related to deep learning? Yes or no?
Yes.
Yes, right? Why? Because this is a type of clustering. It means the clustering don't say that machine learning is a specific machine learning. No. Deep learning has also some characteristics which are associated with machine learning. So that's why it also considered deep learning in the same cluster. So maybe you can have 2 out of 8 books of deep learning. Okay, so this is what clustering do is. So similarly, these parameters, this spread purity is more like how much purity of the contents are related to one cluster. This is measured by some means we will discuss when we will go through these unsupervised algorithms later. Similarly, for the association, like I say you this market basket analysis, support and confidence. Confidence means, let's say there are 10 consumers in your system, then I want to say that how many customers have bought bread and butter together. So this is the confidence or support associated with it. Let's say only 8 of the customers had bought bread and butter and 2 had bought bread and jam. So bread butter has more confidence than bread jam. So this is how you measure these things in unsupervised learning as well. Okay. Next is reinforcement learning. So reinforcement learning, the performance is related to rewards, that the feedback, how homogeneous the cluster. Yes, Priyanshi, it's, you can say that how homogeneous the cluster is. It means basically we say that the similarity in the same cluster should be more and the similarity between clusters should be less. Okay, so this is how we measure these things. Okay. And for reinforcement learning, it's more like penalties and cost. So let's say if I let you know the example of chess. Okay. So chess, what you say is, let's say I make a move. So this move is an action. You have taken a decision to make a move from one place to another. Now, you calculate the penalty. Ki this move, how much it is costing you to get a good reward or a bad reward. So if you are getting a good reward, it is a cost. If you are getting a bad reward, it is a penalty. So you want to reduce the penalty and penalties or cost, you want to reduce that. So somehow it's generally we say that this reinforcement learning is somehow very much different from supervised and unsupervised ones. So when we teach this machine learning, we generally focus on these two types of paradigms, supervised and unsupervised, and reinforcement is quite different from them. So when discuss in the last week, maybe we have some lectures related to reinforcement learning, so we'll come through it. Okay, so how to calculate it, what are the equations? It has more mathematical equations comparison of these supervised. So basically, this was your paradigms, supervised, unsupervised, reinforcement, the performance you can calculate. This is very important. So now we have gone through the basic things that covers this week. That is, first is machine learning. This can chat GPT a reinforcement learning. Actually, chat GPT is, you can say that it's an continuous learning with a feedback, but not reinforcement. Because I don't want to throw you many terms. There is a concept of online learning or continual learning. There is another concept, and
Yes,
there is
ma'am.
where you can simply provide iterative learning, you can say. So what it do is, there are some basically ChatGPT are generative learning. Okay, so it's more like, it's not a feedback, it's like generative AI, right? Generative AI is the new trend in the market of artificial intelligence. What it does is, let's say there are some software where you say, just generate some images of bird, and it will generate you some images, right? So whether that bird is present in the world or not, it doesn't matter, it has some characteristics. Okay, so this chat GPT is more like a generative based learning, but it uses some engines. So basically it is, yes, this class is recorded. Okay, chat GPT is more, it's a form of chatbot, but it has some technology associated behind it. So it has different engines, because we have someone here from IIT Bombay, and transformer is a type of algorithm, you can say. So it can be worked with supervised and unsupervised anything, but you can say chat GPT is a generative AI technique where it uses some concept of different subjects behind it. So there is a maths engine, there is a social engine, there is a maybe some science engine. Okay, so what query you ask, it can read out all the contents present there. So it has a huge amount of data. Let's say you ask a question related to mathematics. So what it does, it try to hold the knowledge of all addition, subtraction, differentiation, and these things, and it try to solve it for you because of that engine that is behind it. But it is also generating the text, generating the equations that are not present in the world. Let's say if you give a random function and say, please find the integration of it, please find the differentiation of it, it will give you some answer. It may or may not be correct, it doesn't matter. That's why it is called generative AI. Okay, all right, so now we will just take some queries, take some questions to solve from last year. In between, we will discuss about bias variance also, because there is this thing left, bias variance, and one thing that someone asked me about linear regression. So I'll just help you that how you can solve that. Okay. So let's start. So I'll give you 1 minute to think about the problem, and you can just write the answers here in the chat box. And if you need any explanation, then we'll explain that also. Okay. Just add this guys also. Okay. What is the question? Ma'am, which ML models are used to implement facial image and speech recognitions? Okay. So basically, Kathy, this facial image and speech recognitions are two branches in, uh, you can say, AI itself. So there is a branch called computer vision. This vision branch, what it does, it takes the input in the form of image and applies supervised, unsupervised, these big networks over it. Okay. For speech recognition, there is a branch called LLMs, that is language modeling, where this chat GPT comes into picture, and these are not actually separate branches. This is also unsupervised way, because some of the tasks are, for example, if I give you an example of a human, you can CNN, yes, it's an mechanism to handle um images particularly, but I look, what I wanted to just keep in mind, these architectures are not specific, these are mathematical architecture. Okay, okay, uh, let me give you an example. Let's say you learn to add elements, right? If I give you two numbers, can you add it? Yes or no? Yes or no? Just let me know. Yes. So
Yes.
addition is an operator. it doesn't matter to you whether I give you number, whether I give you a decimal number, or if I say just add two names. Add two names means concatenate them, right? So it means for a human, it doesn't matter what the input is if you know the operator. So these ANN, RNN, deep learning, machine learning are operators. So let's say this deep learning means it's more like a neural network, right? So as you process your systems, this neural network does like that. So input is given to it, and let me clear you very clearly. Machine don't understand your language. So if you are writing to a machine, okay, hi, my name is Shreya. It is not be written like hi, hi. It doesn't know. It converts into something which is known by the machine, and machine only know numbers. So it encode your all this text into a number format. That's why encoding is important. Okay, after encoding, whether it's a text or an image or a video, it doesn't matter. It's just given as an input, some output is given to you, and that output result should be associated as in the same way. So your output will be a number, your input will be a number. But as a human, you want to do this pre-processing and post-processing. Am I clear? कुछ कुछ समझ आया? Is that clear?
Yes, ma'am.
Okay. And what you have written here, Manaswini, that CNN is related to image processing. Yes. RNN is related to text or time processing. Yes. RNN means some sequence is given to you. So in text, you say that if you are writing like, hi, I am Shreya Bansal. So hi, comma, I, this is a sequence, right? Your time process. And CNN is related to image processing. And let me tell you one thing. There, if you know, do you know anything about spectrograms? Yes or no? Anyone? Spectrograms? No. Let me tell you. When you speak, the physics people know it, okay? Yeah. When you speak, there is a wave, right? All things that we speak, we see are in electromagnetic forms, right? So, an image is generated from your audio. That is called spectrogram, in which some frequencies the graph is shown to you. Those frequencies and those graphs in the form of images from the audio can be passed through CNN. So now CNN is used, which is actually built for images, can process audio also. Similarly, someone has told me in chat box, transformers, right? Initially, the transformers were built for text, as you have written, someone has written RNN. Yes, true, it's a form of recurrent neural network, some form. I will not say complete, but somehow it helps to process this sequential data. Now, this knowledge of transformer is applied to images also. So ultimately, that's why I always say this, try to grasp knowledge. Don't associate yourself to particular examples. You can associate knowledge to any field. That's why this machine learning is in so much trend, because it automates the process for the user. And obviously, I would say, if you are the developer, don't say that you are using an automated system. You are creating that automated system. So you know how the process works. Nothing is automated in this world. But you are the ones who develop it. Okay? So let's start with this exercise. And if you will let me know the answers quickly, then we can further go to the other topics also. Okay? So the first question is, which of the following are supervised learning problems? So think of it. And one thing also, sometimes, let's say, you will say that, ma'am, these are very basic problems, oh, we can skip it also. But let me tell you, sometimes we know these are the simple concepts, supervised, unsupervised. But when it comes for your exams, right? So sometimes we don't understand the basics, but a thing that is above basics. So when you skip those basics, we generally don't able to solve questions. So the another aim of these sessions are just go through the questions so that you can have an idea that these questions will be there in your assignments also. Okay. So first thing is, which of the following are supervised learning problems? So you know about supervised learning. Okay. Option A, clustering Spotify users based on their listening history. Second, weather forecasting using data collected by satellite. Third, predicting tuberculosis using patient's chest x-ray. And last is training a humanoid to walk using a reward system. Now your time
B and C.
starts. Just write it in the chat box because I am not able to listen if all of you speak. Okay, B, C, someone. Okay, just please be attentive. Here it is written as multiple correct. So there will be multiple correct questions. Okay, let me ask you this. If this is a machine learning system which will correct your sheets, and if you write B, C, most of you have written at B and C are the correct options. Okay, means you have got the basics of supervised learning. Very good. And some of you have write only B. Some have write only C. So should your system give you full marks or not? Think of it. So should your system give you full marks or not? No. No. A doubt about question D. Now look, partial marks. Now question arises, this full marks or partial marks are based on your task. If your task is your key either use full marks or no partial marking is allowed. Okay. If partial marking is allowed, you create a system on the basis of that thing. Right? Acha Grishma, ma'am, I have a doubt about question D. Question D, let me know what about question D? This question,
Like all the above you understood, but the D1, why is it not like
okay.
supervised?
Let
Or
me know some if someone of you can associate a learning at option D. Which learning type is of option D? Then I'll let you know. Option B, C are obviously correct answers, but what type of learning paradigm? Supervised, unsupervised, reinforcement to option D? Let me know. No one. Can anyone not tell me that what type of learning will you associate? Do you know what is humanoid? Yes or no? Do you know humanoid? Am I audible? Unsupervised. Okay. Yes, yes. Okay. Let me come again. So basically, the explanation lies here. Like supervised has labeled data, unsupervised has unlabeled data, and reinforcement learning has environment feedbacks. Or yes, correct, correct, correct. Sanjana, some HN reinforcement. Priyanshi, good, very good. Reinforcement learning. So basically, okay. So basically, first thing is unsupervised because this is a type of clustering. It is mentioned there. Second is supervised. You can easily say that. Third is supervised. You all have decoded it very good. Last is training a humanoid. Humanoid means robot. Like the human-like object, you are going to train it to walk using reward system. Reward means, let's say there is you train a robot to walk in left, right, forward, backward direction. Okay, now a obstacle come into okay, be supervised, let me know. Okay, the obstacle comes in between. So if your robot is just moving towards the obstacle, it will obviously get hit into it and will fall down, right? So this is the reward system. Okay, I should these avoid the obstacles and take another path. All right. Second is question is why B is supervised. What is B? Weather forecast using data collected by satellite. Okay. Let me tell you, when you train your system, right? So it means some data is already given to you. Correct, Sanjana? Right? Data is given to you. So some previous data is given to you. Let's say weather forecast can be of different types. If Priyanshi, regression is related if you are predicting the weather thing in a number. For example, let's say you are predicting the humidity, the temperature, the rainfall status, then it is regression. But if I just classify it as sunny, cloudy, or rainy, then it is classification. So I have collected some data from satellite. I associated a label or the ground truth value, the output with it. Okay, and then use that system for my further test. Second is why C is supervised. C is predicting tuberculosis using patient chest X-ray. Just let me know how you will get this system who can easily give you the prediction of tuberculosis. You first tell the system this is the image of a tuberculosis, this is the image of non-tuberculosis, these are the image for tuberculosis, this is the image for non-tuberculosis. Now when you test the system, it will easily give you the correct prediction. Okay, Prasanna. Correct, Rachna input data
Got it.
set. Yes, go ahead.
No, I said got it.
Okay, thank you. Okay, all right. Ma'am, will recommendations come into generally recommendations comes into unsupervised learning. Yes, true. Okay, let's move to next question. So option B and C are correct. Option 2 is the same question. So these are the same task. Some tasks are given to you, and you have to find out which of the following are regression tasks. First is the prediction of an outcome of an election. Second, predicting the weight of giraffe based on its features hoga. Sorry, the weight, I think I have some mistake in writing. Third is prediction of an emotion conveyed by a sentence. And last is identifying abnormal data points. So which are the tasks that are related to regression? Your timer is up. B, someone says A and C. Okay. Regression tasks B and D, A D, A B. Okay. B and D. All right. Many of you are writing as B and D. B is somehow common with you, so you are giving me multiple answers. Okay. So okay, ABC. All right. Any more on ABC, B, D? Okay. Very good. Very good. Now, all right. Okay. Okay, now 15 seconds are left. Anyone else want to? Alright, there are mixed ups in the answers. So let us discuss all these options clearly. Okay, so 3, 2, 1, stop. So you all know supervised learning, that is classification, regression. Classification means discrete category. It means category. It is written as category, okay, and it is continuous value. Now let's start with first thing. First is predicting the outcome of an election. So the outcome of an election is either win or not. So there will be multiple people, and you will get to know the name of the person either who will win, or for a particular person whether he will win or not. Yes or no? Is it? Yes.
Yes,
So
ma'am.
this is not a number, right? Either yes, no is also a class, 1 or 0, or if the name of the person is also a class. So it is a classification algorithm, not regression. So first thing is clear, A is not the answer. Second is prediction of weight. Obviously, the weight in kilograms or any unit of weight can be used here. So the output is in the number. Let us say 62 kg, 78 kg. So this is a number, it means it's a regression. It can be 78.2, it can be 78.02. So this is regression. It's very simple. Alright, B. Third is predicting the emotion. Ronak, Hanji?
Yes, ma'am. Am I audible?
Yes, audible.
Ma'am, sorry, but ma'am, we can also, I think, predict the outcome of an election through regression if we put them in some kind of dummy variables, ma'am. I don't know if I'm going out of the topic or not.
Yeah, madam. Zero is win or lose. One is
If
winning.
if we label zero as lose and
Lose.
one as wins, ma'am.
That's why I told you an example of rating. 1 to 5 rating, if you are taking it in a discrete number, then it's more like a class, not
Yes.
not regression. When 0 1 is also a class, okay, not regression. All right.
Okay.
Acha. Someone has said option we are predicting outcome as a number also. Acha. Option A, we predicting the outcome as a number also. That's what I just say, कि if the number can be 0 1 also, it's more like a class, it's not a actual number, because that number don't denote a quantity, right? It denotes a person, it denotes an expression of win or lose. So it's more like, okay, acha, predicting the outcome of election can contain number of votes, so it can be regression. Actually, the number of votes are features. When you are in the process of election, you count the number of votes, and the outcome of election can never be the number of votes. It's always the whether the win or lose, right? So these the number of votes are the basis on which the outcome is determined. So this vote is your features. We call in this machine learning term as features. Okay. Now let's go with this third. Third is predicting the emotion conveyed by the sentence, as someone also say that rachna, right? Classification, because whether happy, sad, angry, distress. So these are the emotions. So if it is predicting an emotion, then it's a classification task. Secondly, if you are predicting the emotion conveyed by the sentence using clustering also, it is not a regression task. Okay. Last, this is very important because many of you have written D also as regression. Now, identifying abnormal data points. So, this type of analysis in data we called as anomaly detection. ANOMALY, anomaly detection. Anomaly means abnormal data. Abnormal means, let's say, I want you to just, I'm giving you an example. So there is a rainy day, downpour is actually there outside, and just let me know someone who is wearing a umbrella or raincoat is normal or not wearing. I have given you a scenario. There is a huge downpour is there outside. It's heavily raining, and some students are coming in the institute. Wearing raincoat or umbrella is normal, or not wearing is normal. Wearing is normal, right? So generally, when you get these type of data, when you collect, let's say you have a camera at the gate, and you just click the pictures of all the students who are coming out, right? So many of the students, it means, let us say about 98 or 99% of the students will be having this some raincoat or something, right? Maybe because of some reason 1 or 2% are not there, so that those are abnormal data. So how we treat this, we train a system using unsupervised learning using normal data. Okay, and I told you, right, in the last this thing. So we have this distribution, and this is your normal data. Now, one person who is not wearing the raincoat or umbrella has comes into picture. So it means that data will lie very far from this average. So having a distance from this average value will give you an information. The data is, yes, you can say it as noise, outlier, anomaly. So it's more like a unsupervised problem, not supervised. So that's why it is not a regression or these thing. Okay.
Excuse me, madam.
Hanji. Yes.
I have a little doubt.
Yes, sir.
You told in your previous statement both outlier,
Hmm.
yeah, and
Noise. Anomaly.
anomaly,
Hmm.
yeah.
Yes.
Both are same or there may be some difference.
Generally, we use the outlier or noise term which are not needed by your system. Okay, anomalies, maybe we can associate, it's just a use of term in different sense. So we use anomalies, means outlier and noise can be seen as they can disrupt your data, but anomalies can help you in, we use this term where we, you know, want to write in a positive impact of data analysis. Okay, these are the observations that we got out from the data. So generally these terms we can use interchangeably. It's not a big difference.
Ma'am, according to your explanation, anomaly algorithms are boost up our machine learning process, and noise and outlier disrupt our algorithm.
Sir, generally what we do is, when you do pre-processing, for example, let me give you one data, okay? So those data consider the income of an organization, okay? So let's say the income of an organization has different categories. Let's say you have manager, your clerk, or something. So in the clerk category, the maximum, the range of the income is lies between, let's say, some K, right? So let's say from 20,000 to 50,000. And by mistake, I add a zero. So it's more like an outlier or a noise. Why we call it as noise? Because we generally reduce that noise before processing the data. Okay. Now these anomaly detections algorithms are more complex. More complex in the sense we have a huge amount of images in which we have to find out the anomalies. Let's say these things should not comes into the distribution. So it's, yes, you can say fraud detection and these things are anomalies. So anomaly is a more sophisticated term associated with these noise and outliers, but at the basic level we call them as outliers or noise. Am I clear?
Okay, ma'am. Thank you.
Okay. All right. So this is the second. Next question. Next question is, same tasks are given to you, and I think because we have already discussed the same question. Same question is for the same task. The question is to identify the classification task, right? So as we have already discussed in the previous one, then we can just skip it and move towards the next thing, because we have, I think, half an hour left for this, and we want to complete some KNN and other data. Now, this is a common data given to you. So you can see here there are some data points in red, there are some data points in green. You can see that, okay? So two-dimensional plot, two features are given, feature 1 and feature 2. Let's say these are like number of runs and number of wickets as we have discussed. And there are two types of classes. It means it is given to you, one belongs to red class, second belongs to green class. So green can be treated as batsman, red can be treated as bowlers. Just an example. Now, okay, this now two lines are given to you, because classification actually what it means is that to separate two classes with the help of some boundary. Okay, that is called class, just separating the two things. So what we can do is, we have one blue dotted line from which the classes are separated. Another line is this red dotted line, oh sorry, this pink dotted line, which separates all the point actually accurately. Okay. Now, another difference that I give you here is, if my task is, this PPT will be, yes, the PPT will be shared also. So let's say this, if you want to classify data, it means this line, okay, let's say I consider that this blue line is the final outcome. It means this is my line which will help me out to classify data into red and green class. If it is above, the data is above, it is red class. If it is below, it is green class. So this is called classification. Regression means you will have, let's say, what should I have? Okay, so this was your data. Let's say this is your red class. Okay, I'm just giving you an example. And this is your green class. So there is one, this line is there, right? So this line means here it is red, here it is green. Another line is given to you like this. So question arises is, uh, question arises here is how to draw these boundaries. So your algorithms will help to you to draw these boundaries. Which boundary is better, the performance measures will help you to decide. Okay, so let's say you decide this blue boundary where there is a curve. So it means above it there is red, below is there is green. So my question is, what you have asked just before, noise and outliers. Maybe these 2 points, these one, are noise, and they just classified as green, sorry, orange. What if they are actually green but they are in some, due to some noise or some outliers they are there? Okay, so ultimately there are two functions that is given to you, this function, this one, and this one. Now your question is, okay, I was telling you about regression. Okay, so for regression, the same task, the output of a regression lies on this line. If the task is of classification, what you will say, if the data comes above this point, above this line, it is red, and below it is green. But if it is a regression task, the output will be a number. So here the number will be written, right? This is the number line, as you can see. So if I choose this blue as my final boundary, it means if the data is like this here and here, so it will map to this point. So the value here will give you the output. So basically for regression, we plot these lines and over the data we choose the particular value. It means we map x to y. What you do in, I think in 11th standard, you start, means basically you map a function from, you have a function and you have x value and you want a value of y from that, right? Like that. So it's more like a regression thing. That is the regression function. So these are the regression tasks. Here the question is it overfit under? Yes, Kathy, I am coming to this. So the question here is given to you. There will be two questions related to it. Which of the two functions
So this
overfit?
data is regression, ma'am.
This data is classification. Just look at it. It is saying you two classes data. It is not giving you the information that you have to pick a value. The red point belong to one class, the green point belong to another class. Okay. So question is, the data, which of the two functions are overfitted? Okay, both the functions, function 1 or function 2 or none. So let me just go to the function so that you can easily visualize it. This was the function. You have to say which one is overfitting. What is overfitting? Let me give you a small example. You come to this class, okay. I let you know about, let's talk about actually variance and bias and variance. You will get to know. So basically, you come to this class, you want to learn machine learning. Okay? What I do is, I just give you some 10 questions. Okay, to solve in the class. And what some of you, what you did is, you just wrote it. Okay, if the if the question is this, the answer is this. If the question is this, the answer is this. If the question is this, the answer is this. You can treat it as rote learning, or you can say the mechanism of your learning is not good. So that's why in this data we can say this graph, this blue line. Okay, so it means if a function is like that, yes, like this, there is some data maybe, okay, and you just precisely train on it. This is like the data. Okay, my drawing is not good there. So basically, what you have done, you train on the data, but you overfit it. You learn everything about it. there is a drawback. What a drawback will be, because you only see these 10 questions, you are not able to generalize your knowledge on testing data. So the result from the testing data will not be very good, right? That's what I'm telling you. This is overfitting. Overfitting means the function, means our basic objective is to learn this function, this graph, okay, this one, this line. So, do you think it is actually the correct graph? No, we don't know. We just have data. We don't know the distribution. So, what we try to actually grasp it, we try to learn everything. So, if you are learning everything word by word but not able to generalize it, it is called overfitting. So, generally in training, we the error is very less, but when you are going to test your data, your error will be high because you will not able to generalize. Okay. Same concept.
Excuse me, ma'am.
Yes.
Ma'am, can we say that if the suppose there is a test and some unit one unit is given as the test, but instead of learning only one unit, the student learns two or three units, and can we call that as overfitting?
Means you are saying that you have not trained your data on two units, right?
Yes, ma'am.
Let's say if I give you training on cats and dogs but ask you answer on horses, right? Am I correct?
Yes, ma'am.
Right. So it means it is not actually you are not training your system well. No, this is not the task. You can't do that. You actually can't do that. Your data should not be from different tasks. Okay. So because you have seen only cat and dog, so you will classify horse as either as a cat or a dog. It's a different thing. Or it
Yes, ma'am.
so that is not overfitting. That for sure it's not overfitting. It's more like you are not giving the prerequisites are not meeting. You are not training your data properly. Acha, okay,
Yes, ma'am.
I can take the doubts at the end actually. Okay, all right. So I was asking, telling about you overfitting. So underfitting is the opposite concept. Let's say I have given you 10 questions, you have not prepared well these 10 questions, so obviously you will not do well in your test, obviously. So this is called underfitting. It means your data is more like this, but you just keep a simple graph like this. So it will underfit it. So more the error will be there. All right. So these are your overfitting and underfitting concepts. So on the basis of this, you can simply say the F2 is overfitting and F1 is good fit. So we need a mediator in between, where you can say that this F1 and F2, the F1 is good fitted and F2 is overfitted. So basically the answer is the function 2 is overfitted. So I'll just go through the answer. Okay. Similarly, the next question is related to the same figure, that which of the two function will yield high training error. So high training error means obviously the function which is overfitting will not give you training error. It means you are highly overfitted on your data, on the training data. So it means the remaining function will be having higher training error. So the options are the same, and look,
Hello?
function, yes,
Hello, ma'am.
yes,
Hello.
yes. I think I'm not audible to you. Okay, the two options are given to you. Please see here. Both functions f1 and f2 will have same training error. This is obviously not correct. Last is cannot be determined. Many of you can write here. This can how can we determine the training error? Maybe the function is well fitted, so it will not yield high training error, it will be good. So but the question which you face here is, you have to tell which of the two function will yield high training error. It is not giving you asking you for absolute whether it is high or low. It is making you to compare two functions. So that's why the answer will be either function 1 or function 2. As from the previous question, the f2 is overfitting. That's why the answer will be f1. So let's move to the sixth question. It's a very simple question. Okay, ma'am. Weight is high training error. What is high training error? Means I give you an example. You are coming here, I give you 10 questions, I tell you everything, but you don't learn well. Okay, so this is training. So if you are not learning, which I am teaching you right in the class, it means your training error is high. Am I correct? Am I clear, Vishnu? Next question is okay. Next question is what is policy? So basically, it's more like a state fact. In reinforcement learning, policy means the strategy how to choose action. So answer is D. Okay, I am going towards basically. I'm not covering the this factual questions because the I will share the PPTs and it will let you know that the term that is policy. It means a nahi. Just look at it. The strategy the agent follows to choose action. It means the set of rules governing the environment is not policy, it's a part of the system, right? If you know, I tell you the rules of the game, those are not policy, but what steps you are taking after this move is the policy. So basically, underfit give high training error. Yes, Shweta, underfit give high training error. Okay, एम आई गुड? यहाँ तक सब ठीक है? चलें आगे? Okay, thank you. All right. Next question is this is related to KNN. Okay. So at the starting, some of you asked me to how to go with this regression. I'll tell you this at the end after 8 actually because we will cross the time. So basically, just let me know. Yes, I can't actually properly do it right now because it needs a lot of calculation. But I'll let you know because linear regression is in your second week. So most probably, yes. Okay. So can you please brief understand? Okay, Ronak, can you please be here after 8? If yes, I can explain you after that. If it is good to you. Okay, thank you. So basically, KNN regression. Let me know who don't know about KNN regression as it is given you in your lectures also. If you don't know anything about it, then we'll discuss in detail. Okay, KNN. KNN means K nearest neighbor. Okay, so let me just ask you. Let's say you enter a class, you are a teacher, and you know about your class. Okay, so now what you do is there a new student came, and that student go and sit at the backbenchers with the backbenchers. The students who he sit with create a lot of noise. What do you get? Uh, Means how will you classify that student? Need detail. Yes, I am giving you that. I am giving you a scenario. You are a teacher. You are in a class. Some new student comes into the class. After 2 days, you see that that student is sitting with the students who are noisy. Means who create noise in the class. So how will you classify that student? Is the student is also a noisy student for you? Yes or no? Yes. It's just because that belongs to the neighbor who are creating noise. Okay, this is what is KNN is. So KNN means you have some data. So X and Y are given to you, and this data, let's say point 0.1, point 0.2, point 0.3, point 0.4, point 0.5. Okay. Now question is asked, will 2 or 3 belong to which class? This is also a data. So this is a new student and some students are already given to you and their classes is also given. Okay, whether they are noisy or studious. ठीक है, studious, noisy, these are given to you. So how what you will do is you just find okay, all right, Shweta. So what you will do is you will just use this thing and create a distance between all the points. So what is the distance between this point and this point, 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 this point and this point? Okay, simple. Just calculate the Euclidean distance. You know the formula. It is written in the PPT also. Now it is saying 3NN means you find 3 nearest neighbor. So 3 nearest neighbor means the 3 nearest neighbor where you can access uh, the distance, minimum distance, मतलब last three minimum distance. Let's say the distance. I'm just supposing the distance. Let's not suppose it. It is solved. Okay, so you can see here the distance is d is equal to, so there these are the distances that I get it from the given data point. So I just find out the nearest distance, nearest three distances. Okay, so nearest three distances means this 3, 1 and 2, 1, 2 and 3. So this 1, 2 and 3 I labelized it, and the output given from these things is taken as an average. So it's a simple KNN regression. And for the linear regression, let me tell you that what is linear regression. Basically, linear regression, what it does is just, it actually needs some understanding of mathematics. So basically, you have two data points, x and y. You plot them, whichever the plot is. Now, question is, you want to create a function, which I am telling you. Let's say the function is, you plotted first function, okay? Second function you plot is like this, and this is your actual function, because regression is also supervised learning. So that's why you know the actual function or actual values, it means. Okay, so these are the values that are given to you. This one, this one, this one, this one, this one, this one, this one. Okay, now I want to calculate this point. So what I will do, I will just make, if the function is this, the y value will be this. If the function is above 1, the y value will be this. Alright, and I have the actual ground truth of this function, because this is a supervised learning. So there is a concept where you want to fit this line. So fitting the line, I'll just guide you, Shweta. Either search for, there are two ways. One is a very simple way where you use some transpose of it. Means you write this whole of the system. Do you know this equation y is equal to mx plus c? Yes or no?
Yes, 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 sir.
Right? So it's more like, it is, this is a line of equation. But what if say ki I want to have this curve. So this curve has a line like y is equal to a x square plus bx plus c. Or you can say more, in more generalized form, you can write it a1 x1 x1 something like n plus a2 x2 n minus 1, like this, right? You can write a big polynomial equation.
Yeah,
Okay,
yeah, yeah.
so
Yeah.
when you solve it now, so this makes you, helps to calculate this, estimate this value of y. So this is called actually regression. Linear regression ke liye you can simply use this. Or
No, actually, the question is like for the k nearest neighbors itself, a table of values of x and y, and the output for that is also given. So we are given another point which is not in the table and asked to use the least squares estimate to find it out. So, what is the procedure to be followed for that?
okay, just do one thing. Create a system like this for the given data. Okay, so it means you will get to know this a. If I say this one, you will get to know the value of m and c.
Yeah, but it will be different for each set of points, no?
No,
Actually,
that's why I'm telling you this. This is to be learned. It means generally we have an equation like this: x transpose inverse. I don't remember the equation right now, but this is the.
actually, the reason why I asked is even though we had, or this was this type of problem is there in our assignment also. That is why I could not solve this problem. That's why I asked this.
Okay,
Yes, ma'am, exactly. We are,
So
I
actually,
could
also,
you explain the procedure alone? You don't have to tell what is to be done for that problem or anything, but the procedure, because that was not given in the week one's lectures.
actually, it is given in, I think, week 2 lectures, because it is related to regression. If
Yeah,
I'm
maybe.
not
But,
correct, if you can
okay.
go through
So if we
that.
listen to that, we may be able to solve this, you're saying.
Yes. Actually, there is a concept of back propagation there, or you can say gradient.
Okay.
So I have
Okay,
to
okay.
give you lot of terms and
Maybe by next week, if you can give us the procedure, that is enough
yeah, sure,
because
sure, sure.
our date
Okay,
of submission is only 5th, I think.
okay. Then okay, I'll surely give you this linear
That's
regression
fine. Then you
topic.
can move on. That's
Yes.
fine. Thanks.
Okay.
Okay.
Thank you, Zinke. Okay, so uh, self and previous. Okay, okay.
Can you show the question of this?
Sorry, can you please repeat?
Show the question.
Sorry.
Can you please show the question, ma'am?
Acha, question, is it not visible?
Like here, answer is there, no, ma'am. I just wanted to see the question, the tabular.
Acha, okay. This is the question. Okay.
Okay, ma'am, thank you.
Okay. You have seen if Euclidean distance we are calculating as same output, it means 2 points are equidistant from the both points, right? So you can either choose one of them. Khyati. Only KNN regression was solved.
I was replying to Hemalata's
Acha, acha, okay,
message.
okay, okay, okay. Actually, what I have seen is in the next week lectures, definitely it is solved using regression. So maybe there
Then it's
will.
fine. We
Huh.
can move on. No problem.
Okay, okay. So basically, you can simply average out those 3 points. If 3 NN is given, if 7 NN is given, you have to choose 7 points. This how you can easily go on with the k number of neighboring points. Okay. Next question is related to okay, bias and variance. Now bias and variance, let's come to the concept of bias and variance. So the question here is related to if the k nearest neighbor, this k is a very important factor. So if you increase the number of k, what happened to bias and what happened to its variance, it is actually asked. So the bias of the classified decreases or increases or does not change or cannot be determined. So before this we have to go through what is bias. Okay, so bias is very simple thing.
Ma'am, excuse me, ma'am. Someone
Yes.
is unmuted. Can you please mute them, ma'am?
Someone is unmuted. Presently, everyone is muted. Okay.
No, one Sri Tajuddin, I think, is unmuted.
Okay, now it is okay. All right. Thank you. So, what is bias? Bias means the error introduced by approximating a real world problem with a simplified model. Means, let's say you have a data, okay, and you created a model, very simple model, okay, because you have more complex models to a particular types of data, but you just started with very simple model. So the error that is introduced by using this simple model is called bias. Okay. So similarly, so for the number of k's, it means as you increase the number of k, you are having more number of neighbors. So the neighborhood, actual, the small number of neighbors don't make a big impact. So let's say the nearest neighbor is of class A, or some, let's say कि some 5 nearest neighbor are of class A, but the 50 nearest neighbor have more majority of class B. So you will classify the particular data as class B because you are taking 50 as the number of neighboring parameters, right? So that's why the more number of k will reduce the effect of local neighborhood. So basically, when you will increase the number of k, the decision boundary is that the line or the curve become very smooth. Okay, the no for the low number of k, you have multiple fluctuations. Like you can see it as like this is a graph. Okay, and there are some points. This. Okay. Now there is a point that I want to classify this one. What I wanted to do, I want to find out the nearest neighbor. So its nearest neighbor is maybe like this. So if I choose one as the nearest neighbor for this element, I will classify it as the class it is given here. Another point is here. Okay. If I choose just a single number of neighbor, then it is near to this, it will be classified like this. So the graph of this will be fluctuating like this, okay, because the nearest one neighbor is very important. So that's why this type of graph means overfitting. Simple. So the less number of k means it is the decision boundaries are highly flexible, and if you increase the number of k, more smooth boundaries are given to you. Okay, if the boundary is flexible, it is overfitting. If the boundary is very smooth, it means it is underfitting. And I just tell you one thing, means this is the actually a trick that I used to keep in mind. There is two things, bias and variance. Okay, bias means same thing. It means that you are coming here to learn machine learning, and I just tell you about supervised. It means you are biased toward supervised learning. This is called biasness. Variance means I give you multiple terms like look, this is machine learning, deep learning, ANN, CNN, RNN, and transformers, and this computer vision. I let you many terms at one throw. This is called variance, variety. And there are two terms, underfitting and overfitting. Okay, just remember always, overfitting has this V for variance. It means here variance is high. Overfitting, variance is high. If variance is high, then bias is low. And opposite is for underfitting. Got it? It will means you will never forget this in your life. Overfitting has V in it. V for variance means more variance. If you give more variance to a system and reduce the bias, it bias meaning I am giving you so many terms, but I am not giving you minimum examples to um, make you understand a single term. So this is called bias is very low, but variance is very high. Oh, this is machine learning, this is RNN, this is CNN, but I'm not giving you actual thing that okay, the RNN is like this, CNN is like this. Now you are not able to learn that what is CNN and RNN. So it means it is making you overfit. Underfit means I'm just telling you about supervised. You won't have any variance. So you are already underfit because in machine learning you will be asked about unsupervised also. You will not be able to answer it. So it means it is underfit. So it's a basic trick that I generally use to follow. So the question that we were having is if overfitting is there, obviously the bias will be low. So now you have to join the tracks and the answer will be simple that if the k nearest neighbor are there, it means the answer is the bias will be increased. Because as the number of value of k increase, it means it goes to underfitting, and if it is underfitting, the bias is increased. Okay, clear? Next, ninth question. Ninth question is also similar actually. Bias and variance are given by these equations. This is actually the last question because 10th question is very simple. So, can anyone let me know what this E here represent?
Excuse me, ma'am.
Yes.
Just I recall the previous discussion which you are shown in your graph. If we increases the number of value of k in k nearest neighbor, है ना? If k increases, the biasness uh, means upper arrow means what you want to
No.
say,
Okay. Let you.
because it's a very smart way to recall all these
Okay.
things.
The two things are there, underfit, overfit. Overfit has OVER spelling. Okay. This. So its overfitting means the variance is high. Overfitting variance is high, then underfitting variance is low, and opposite is with the bias. Got it?
But in this picture, the value of k in
I am
the
not talking
number of
about
k.
K. I am not talking about K.
Okay,
If you
okay. It's a
increase the
generalized. It's
if you
generalized.
increase the number of K, the graph will be like fluctuating.
Yeah,
So
yeah. I
more
understood.
fluctuation means over. Okay.
Yeah, yeah.
All
Okay.
right. I was asking about this E. Very good. Those who have written this E means expectations. Okay. Let me tell you about this one. So two equations are given to you, bias and variance. Let me tell you a very simple trick for this also. Don't get afraid of these, oh, these equations are written, what we will do. Just a simple technique. You know what is variance. You actually your portal will be having these all these videos, okay? The same portal. So bias means, as I already told you, the error between the truth and the predicted model. What I tell you about bias means when you create a simple model, then how far it is from the actual one. right? So what is the error in the simple model? So error means the difference between the expected result and the true result. Okay, so look here, this cap means expected result. So true means the simple function fx. The expected result means what you are expecting from a model. Okay, so bias means if you have a simple model and how it is far from the ground truth. So what I am doing is I am creating a simple model. I from all the samples I create an average. I calculate the average of the predicted one, right? So this average means E. So it means take the average of all the predicted values and how far it is from the ground truth is actual bias. So that's why you can write it here as E of f cap x minus fx or vice versa. Because generally we take mod or take square of these terms so that we can calculate effectively. Okay. So your correct answer is this: the deviation from this expected result minus the ground truth. And this is the correct thing to write. I have written it here. I will just rectify it. First, your expected value is there, and then you have to find out how far it is from the ground truth. So it's like this one. This is the first thing. The true function is deviated from the expected one. Okay. Now, variance. Variance means, do you know what is the formula of variance in statistics? It's a mean square error, right?
From the mean values.
Right? Deviation from the mean values, right? So here I'm also doing like this. So it is the variation of model's prediction. Okay? So cap means predicted, the model output. If the cap is not there, it means it is a true output which you wanted to replicate. Okay, so here variance means the variation in the model prediction. So it's the this formula is of simple variance. If f dash a, if f cap x is any variable, just replace this f cap x with any variable. It's an equation of simple calculation of variance. Now for variance, what we for which term we need variance? The model prediction. That's why we write it as f cap x. We say average prediction value. uh, if cap means predicted, e means average, and if you are this the formula of e of fx minus e of fx the whole square is the formula for variance. Let me tell you like this. Okay. Okay, how do you calculate variance? Let's say this is your x1, x2, x3, x4. Four values are there, and your average is x bar. So what you do? x1 minus x bar, x2 minus x bar, x3 minus x bar, x4 minus x bar. Right? You take their square and take the average. Is it true or not? Yes or no? Is this variance or not? True or false? This is how you calculate the variance of any variable x. Yes, good. Right? Now what I am saying, I want to calculate the variance of f cap x. It means this is y cap, which is output from the model. Model output. It means this is predicted value. This is not true value, this is predicted value. So I'll just replace x by this function. So what I will do, from x1, x2, x3, I can write it as f dash x minus x bar. This is the mean. So mean, how what I can write? I can use expectation for mean. So I will use, for mean I'll write e of f dash x. This one. What I have done, take the square and then take an average. It's a simple formula. Okay, so whenever you are going to get these formulas, just break it down. Just think of the definition and you will able to grasp that which formula is accurate. So now variance is calculated on the predicted values. So how much variance is present on your predicted outcomes? This is what variance is. It means, let's say your variance, like let's say your predicted outcome average is 5 and your variance come as 25. So it means 5 plus minus 25 is your range of your output. Okay, so in this variation you have the data. This is what actually we wanted to know. Okay, so this is about this question number 9. So the correct answer is this A portion. Another are the,
Ma'am,
yes,
ma'am,
yes.
ma'am, can you tell again why A is the correct answer? I understood bias and variance, but I'm not able to get why A is the correct option.
Look, the for the variance part or bias part?
Ma'am, for the bias one.
Bias one. Bias means, bias say that ki let's say you have a simple model. Now for this simple model, what is your error on your true data? Okay. So what I wanted this, let's say I created a simple model, okay, and I got some output like y1 cap, y2 cap, y3 cap, and so on. These are cap means output. Now I take an average. So I take an average. Average I denoted as E. This, it's not between the difference between y and y cap, it is the difference between y and expectation of y cap. It means this expectation, this average value of y cap, how far it is from actual y. It means from the y, each y, right? Let's say I have 5 data points here. Okay, so 5 data points here are y1, y2, y3, y4. So I just minus it, the average of all this. So expectation of y cap. Actually, it should be written not like this. Here it should be minus, not here. Wait. Something is. So basically what I wanted, there are y1, y2, y3, y4, okay, and now you have E of y cap. So you just subtract each of y from this E of y cap. So this is your final, wait a minute, if I am telling you wrong, no, I'm telling you correct. So this is your actually, okay, so you just, so this is your output and the expected output. How far it is from your expected output. So y2, how far it is from expected output. So this is how you can calculate the bias. Okay. Is it clear?
Yes, ma'am. Thank you.
What is the difference between option A and B? Option A and B, the square terms are differently used. The brackets, just think about just see the brackets, okay? So the brackets are not equal. One square bracket is square and the brackets are not same. You can see it, okay? Next is last question 10. What is false related to bias and variance? So you have the model which overfit had low bias or high bias, or underfit high variance or low variance. Now you have an complete, I give you a trick. So just let me know the correct answer. It will be very easy for you, okay? How far predictive value? Yes, correct. Miss Rin. Okay, you are giving me the different answers this time also. I told you overfit means high variance or high bias. Just let me know. Some are saying, just look, just see the question.
Overfit means low bias and high variance.
Very good. I just want to tell you guys, just read the question, which of the statement are false, not true. Now let me know the correct answer. Many of you will be like ticking that what is true, okay? So please read out the questions very carefully. So BD still I'm not BD. Okay, overfit will be having low bias. Timer is up. Same explanation is there. The answer will be B and C, because I am also giving you the hint that false statement are to be find out. So it means first A is true. D is true. A, D are true. And I am asking you which statements are false. So the correct answer will be B and C. Please read out the questions carefully whether it is asking for you either for true statements or false statements. Okay. So this was the last question. Thank you so much for your time. And this is the form. Please, if you can just share your suggestions or feedback, or if you have any doubts or anything else, just write it in the form. This form is just for me, it is not shared with anyone else, and it is anonymous. So I'm not be
Ma'am,
judging you.
ma'am,
Okay? Yes, yes.
ma'am, previous day there was a one session and you take another session. So which session we will join?
It's for your convenience that you can join any session.
Sir has been
Okay.
sir had been taken one session on Saturday or Sunday maybe. I joined that session, but you now taking another session.
Himanshu, let me. So there are four teaching assistants for you. We will be taking session on different days. I think Saturday, Sunday, and Monday and Tuesday are four sessions. So the rest three sessions will be taken by other TAs. This Tuesday session will be taken by me. So whenever you are comfortable, whenever and
Ma'am,
which session you want to,
all
you
this
can
session,
attend.
the
if you want to
content,
attend if you want to attend all session, you can attend. It's your choice. It's
ma'am,
just for
in,
guided sessions.
ma'am, in all session the content is same.
No, we don't share contents with us. Okay, so you can have means maybe they have trying to give you some more idea about coding or something. I don't know about those sessions. You can join them, and means whatever you like, it's up to you. Okay.
So the content may be different in
Yes,
different.
yes, yes, yes. These are for your queries taking session. If you want to, if you have some queries, you can join the session and ask your queries there. Okay. All right. Thank you so much.
Ma'am, just a minute, actually.
Yes, yes.
That same question on KNN, no? Could you explain that with respect to the linear regression also, that same question? Just the steps, how
Wait
to
a
do
minute.
it.
Wait a minute. This barcode, this QR code on your screen is the link for the feedback form. So please scan this QR code. Okay. Recordings and PPTs will be shared you by the team of NPTEL. Okay. Uh, Maybe they will be made available to you after this session because this is your last session of first week. Okay. All right. Or you can ask your query. The QR is not working. It's not like that. I have checked it. Wait a minute. Yes, Shweta, you can ask your question please once more.
No, that same question, the steps to solve the KNNs, instead of KNN, how to do with linear regression. You have n number of points with x1, x2, and y. Suppose you have 10 points, which is for which x1 and x2 are given, and the corresponding y value is also given.
So, ma'am, intercept and slope values, how we find and how we calculate the predicted y.
Okay,
No,
actually,
same question. Is it Ms. Renuka? You're also asking the same question?
Yeah, ma'am, exactly the same question. I'm not able to solve the question on
Yeah, that question
assignment.
even I was not able to solve.
actually, I will. It's a pro. It has look. It has two ways. I'm telling you very clearly. It
So if
has
you
two
can
ways.
just show your
If
KNN example itself, it'll be easy. This
Yeah,
KNN, you
exactly.
have that example here. That
Yeah.
example you can show us.
right now I can't show that because it takes a lot of time, and but certainly I'll complete that thing in the next session. Okay, in the PPT as well.
Okay, but
So
overall, the steps to be followed.
that's why I'm saying कि, I have to look through how which method sir has gone through the same terminology so that you cannot get confused. Okay, so I'll look into
So
it.
they have said least squares error method. Least squares error.
Least square error method is same method, ma'am. In mathematics, we called it as least square method. It's the same thing.
Okay.
It's a concept of linear algebra. You can easily get that. Least square method is a simple method where just treat the x1, x2, and y values as matrices. X and y. Okay.
Okay.
So now use the projection, some it's a least square method is an application of projection. So use some inverse projection to find out the value of y, or to create a linear equation of y actually.
Ma'am, ma'am, is there any shortcut method to find out all these? Because it takes more time to solve a small problem.
Ma'am, it's actually it's a like you are having only six values, so the matrix is quite low, right? It's not a high dimensional data. You can easily solve it. It's like x transpose inverse, something like that. So you have to take the inverse of those things, and there is an equation I don't remember right now, but I'll come up to it by the next session.
Okay, ma'am.
Okay, then.
Okay. Yeah, you can. Manaswini, differentiation of each variable comes into picture when you start reading all these things from basic things, and you are going to get an objective function. For example, our main objective is to minimize this equation of line. Okay, this equation of line with our respective outputs. So basically, I don't want the error to be high, so the error is to be minimized. If a feedback form is loading something, someone is saying it is working. Okay, so basically, if you are choosing that way, then it's also good. And least square method are more like it's a shortcuts, you can say, because it's related to projection. And these linear equations are, if you are going into deeper multivariables, it is like a projection variable. So either you can learn about projections in that least squares, you can learn about it. There is a book of this Gilbert, in which these questions are given you in a good way. Gilbert's Strand, this book, for linear regression, linear algebra, and for this least square methods, you can find out some questions. Otherwise, by this method, what you are saying about differentiation, it means we are going towards optimization. So, if I include all these terms here in the first lecture, I think you all will get confused. So that's why let
Excuse me, ma'am.
me, yes.
And can you please show the ninth question slide?
Okay, okay, wait. Ninth, this one.
Yes, ma'am.
Aditi, these guided sessions are not sequential, so these are just to guide you. Okay, generally we try to cover what we have in you have in your PPTs and videos that is given to you course material, and we try to solve some questions of previous years. So this is the question. These are the assignments from previous years. So basically. Means you can join the sessions by the next time. It's okay.
Hello, good evening, ma'am.
Good evening.
Ma'am, when will be we get our assignment?
Your assignment is actually online. It is, I think, maybe given to you on your email.
Ma'am, it is already posted, ma'am.
It is already posted now.
Yes, ma'am.
Okay. So, all right, just check out your mails. If you have, I think some query mail is also given to you. You can ask your queries there. And related to remaining supervised random forest trees, etc. I don't have those questions right now. So if time permits, we can include them because it's a
Okay,
big
ma'am.
course. We can't, it's just a 2 hours lecture, so I can't cover many things in this 2 hours. So that's why I have given you the feedback form. I can't guarantee you that I'll just go through every thing that you will write to me, but I'll try to make up for it. Okay. Last date, you have to check your emails. So please go ahead. All right. All good. So shall we leave?
Yeah, thank you. It
Thank you,
was a
ma'am.
nice
Okay.
session.
Thank you so much.
Thank you, ma'am.
Thank you.
Thank you, ma'am. The
Thank you.
session was good.